Some of the working examples are given here in this section. Short-term production function is given as Q equal to 10 plus 6L minus L square. Find average product of labor, margin of product of labor, unit of factor labor that will maximize total output. Find total output APL, MPL at that point. We want to find the value of these functions. Given the short-run production function Q equal to 10 plus QL minus L square. Average product of labor equal to Q divided by L, that is Q by L. 10 plus 6L minus L square by L equal to 10 by L plus 6 minus L. 6L by L is 6 minus L square by L is L minus L. Margin product equal to labor equal to the first differential of this function, or take the differential of this Q. dq by dl equal to 6 minus 2l. The employment of input that maximize total product is the level of input where margin of product is 0. That is, when margin of product of labor equal to 0, total product will be the maximum. That is, margin of product is given as 6 minus 2l equal to 0. That is 6 equal to 12, L equal to 3. When labor equal to 3, the total product will be maximized. Then the value of total product equal to substitute the value of L equal to 3 into the total output. That will equal to 19. Average product at L equal to 3, substitute L equal to 3 into the average product of labor function 6.33, and marginal product of labor equal to 6 minus 2L equal to, that will be equal to 0. Then total product is maximum, marginal product will be 0. Another question is, given the production function Q equal to 5L raised to 1 by 2, find marginal product of labor. Marginal product of labor is differentiate this function with respect to the L. That is, d by dl of 5L raised to 1 by 2. 5L raised to 1 by 2 is 5 into 1 by 2, L raised to 1 by 2 minus 1. That is 2. 5 into 1 by 2 is 2.5. L raised to minus 1 by 2 minus 1 is 1 by 2 minus 1 is minus 1 by 2. That is 2.5. L raised to minus 1 by 2 is the marginal product of labor. Another example is given the production function as Q equal to a function of K and L, and where Q capital K is the fixed factor and labor L is the variable factor, so that Q a function of labor, and the functional relationship is given as, that is, here the production function is Q equal to a function of K and L. It is assumed that K is the fixed factor, and therefore the function is given in terms of labor, that is in terms of the variable factor 16L plus 3L square minus L cube by 3. Find the labor unit required to produce maximum output, value of maximum marginal product, unit of labor which maximize average product. What is the maximum APL? Show that when APL is maximum, APL equal to MPL. The first question is the employment of unit labor that will maximize the output Q is at the point where MPL equal to 0. That is, find the value of marginal product of labor from this function. That is, differentiate this function with respect to L. Then we will get the marginal product of labor. At marginal product of labor equal to 0, total product will be the maximum. Marginal product of labor is 16 plus 6L minus L square. Then this will be equal to 0. 16 plus 6L minus L square equal to 0. Solving for this is a quadratic equation. A square is minus 1, B is 6 and C is 16. Substitute this into the equation. That is minus of 6 root of B is 6 square minus 4 into minus 1 into 16, that is 64. 6 minus 6, minus of minus 6 is 6. 6 plus or minus root of 36 plus 64 by 2, that is 6 plus or minus root of 100 by 2. 6 plus or minus 10 by 2, that is 16 by 2 equal to 4. 6 minus 10 equal to minus 4 by 2 is 2, minus 2. That is L equal to 8 or 2. Since labor cannot be negative, MPL equal to 0 when L equal to 8. Thus total output Q is maximum when L equal to labor. 8 labor are employed. Then find the maximum value of labor margin, maximum value of marginal product of labor. The first order condition is marginal product. The differential of this marginal product equal to 0, and the second order condition for maximum is less than 0. For minimum it is greater than 0, for maximum it should be less than 0. D by dl of MPL equal to 16 plus 6L minus L square equal to 0, that is 6 minus 12, that is the differential of this function is 6 minus 12 equal to 0, L equal to 3. D square MPL by DL square equal to minus 2, that is differential of this function equal to minus 2, this is less than 0, therefore L equal to, at L equal to 3, marginal product of labor is maximum, and the maximum value of L equal to, substitute L equal to 3 into the MPL function, that equal to 25. Then third question is the unit of labor that maximize average product of labor is obtained by maximizing APL with respect to the L. Here we want to find the maximum value of APL and the value of L at this point. Therefore the conditions are first order condition equal to 0, second order condition less than 0, then find the differential of APL. First take the first differential, that is APL equal to 16L plus 3L square minus L cube by 3. Differential of this equal to 16L, 16 plus 3, differential of 3L square equal to 3L minus L cube by 3. L square by L cube by 3 is minus L square by 3. Average, then take the differential of this function. The average product equal to the total product divided by L, that is 16L plus 3L square minus L cube by 3 by L, that is 16 plus 3L minus L square by 3. Then take the differential of this function, d by dl of 16 plus 3L minus L square by 3 equal to, this is 0, this is 3 minus L square by 3 minus 2 by 3 into L, that is 3 minus, here the differential of take the differential of this average product of labor, that is d by dl of 16 plus 3L minus L square by 3, that is differential of 16 is 0, then differential of 3L is 3, differential of L square by 3 is 2L by 3, that is given here, minus 2L by 3 or 2 by 3 into L, that is 2 by 3 L equal to 3 means L equal to 9L equal to 2 or L equal to 4.9 by 2 equal to 4.5. 2 by 3 L equal to 3 means 9L equal to 2, therefore L equal to 9 by 2 equal to 4.5. Then dou square APL by dou L square equal to differential of, take the differential of this function, differential of 3 is 0, minus 2 by 3 L is minus 2 by 3. This is less than 0. Therefore, APL is maximum at L equal to 4.5. And find the value of APL at L equal to 4. Substitute L equal to 4.5 into the APL function. This is the APL function. Then we will get 22.75. Then fourth question is when APL is maximum, APL equal to MPL. APL is given as this one at AP. L equal to 45. This value is 20 point. MPL is 16 plus 66L minus L square at L equal to 45. Substitute L equal to 4.5 into this function. Then we will, that is at when APL is maximum, APL equal to MPL. Next example is given the Cobb-Douglas production function Q equal to A k raised to alpha L raised to beta. Find marginal product of capital, marginal product of labor, average product of labor, average product of capital. Marginal product of capital is, differentiate this with respect to K, that is dou Q by K equal to A. Marginal product of K equal to dou Q by dou K, that is differentiate this function with respect to K. A is constant, A, that is differentiate K raised to alpha. Differential of K raised to alpha is alpha K raised to alpha minus 1. That is alpha K raised to alpha minus 1. L is constant, it is a product in product term, keep it as constant. Likewise, L raised to beta, that is alpha into A, K raised to alpha, L raised to beta by K raised to this k raised to alpha minus 1 can be split into 2, k raised to alpha into k raised to minus 1, then k raised to minus 1 is taken to the denominator, that it will be equal to k raised to 1. That is alpha a k raised to alpha L raised to beta is nothing but q, alpha into q by k. Likewise, marginal product of labor equal to dou q by dou L, that is differentiate this function with respect to the labor. A is constant, k raised to alpha is constant, then differential of L raised to beta is beta into L raised to beta minus 1. That is given here, beta into a, this split into L raised to beta, L raised to L raised to minus 1, then L raised to minus 1 is taken to the denominator, then we will get beta into a k raised to alpha L raised to beta by L, that is beta into q by L. Average product of labor is q by L. Q by L means divide this by L, then we'll get a k raised to alpha L raised to beta minus 1. This can be taken to this side. Average product of capital is equal to a k raised to alpha L raised to beta by k. This can be taken to this side, that is a k raised to alpha minus 1 into L raised to beta. Given the following production function, q equal to L raised to 0.75, k raised to 0.25. Find the marginal product of capital, marginal product of labor, average product of labor, average product of, that is differentiate this with respect to k, then we will get marginal product of capital. Differentiate this with respect to labor, we will get marginal product of labor, then divided by L, we will get average product of labor, divided by k, we will get the marginal average product of capital. That is differential of the dou by dou k of L raised to 0.75, k raised to 0.25 equal to, first take the differential of with respect to L. L raised to 0. Differential of L raised to 0.75 is 0.75 L raised to 0.75 minus 1. K is constant, k keep it as such, k raised to 0.25, that is 0.75 L raised to 0.75 minus 1 is minus 0.25, that is k raised to 2.5. Then marginal product of labor is dou q by dou L, dou by dou L of L raised to 0.75, 0.6 k raised to 0.25, then 0.25 L raised to 0.75 k raised to 0.25 minus 1, that is 0.25 L raised to 0.75 k raised to minus, that is here 2.5, 0.25 minus 1 is minus 0.75. Then average product of labor is q by L, that is this divided by L, L raised to 0.75 minus 1 k raised to 0.25, that is L raised to 0.25 k raised to 0. This can be taken to the denominator, then it will be positive, k raised to 0.25 divided by L raised to 0.2, that is k by L, that the power is same, therefore it is a common form, k by L raised to 0.25. Likewise, average product of capital equal to q by k. L raised to 0.75, k raised to 0.25 divided by k. L raised to 0.5, k raised to 0.25 minus 1 equal to L raised to 0.75, k raised to minus 0.75. Take this to the denominator, we will get k by L. This L. Take the k to the denominator, we will get k raised to 0.75, that is L by k raised to 0.75. Next question is the production function of a commodity is given as q equal to a function of KL, and the given production function is q equal to 7L plus 3K minus 2L square plus 6K square plus 7KL. Find the marginal product of labor, marginal product of capital, marginal labor and capital at L equal to 2 and K2. That is q is given, then MPK equal to dou q by k. Differentiate this with respect to k. Here differential of 7L plus 3K minus 2L square plus 6K square plus 7KL with respect to L is, this is 0, this will give 3, this is 0, this will give 12K, this will give 7L. Likewise, marginal product of labor equal to dou Q by dou L, that is dou by dou K of 7L plus 3K minus 2L square plus 6K square plus 7KL, that is 7 minus 4L plus 7K. When L equal to 2, K equal to 3, marginal product of K equal to, let's substitute L equal to 2, K equal to 3, and both these function will get the value of function.